let's look at some examples. Okay. So let's look at the path. Okay. 1, 2, 1, 2, 5, 6. That's one possible path in this control flow graph. Okay. So I want to ask you, is this path 1, 2, 5, 6 definitely for variable x? So in node 1 we have a definition of x, right? In node 6 we have a use of x, right? So remember that DOP is a definition, okay, of definition and use. So now we have a path from node 1 to node 6. Is this path definitely
For x, right?
for x?
I think so.
So you do not have any definition of x in the middle, right? Okay. So it is definitely for x. Is it definitely for y? Why not?
The one at the end.
The y in the end, okay? Again, that comes to the point I mentioned earlier. See, this variable y can also come. They appear in both def sets, the set, and also use set. In this case, so basically in the same basic block, you both define and use x, use y, right, and count as well. In this case, we have to look at the code, okay, to see which one occurs first. So what we do is that we come back here, node 6, okay, corresponds to statements 14, 15, 16, okay. If you look at the use of y and the definition of y, they take place in this statement 14, right? Which one occurs first? The use occurs before the definition, the redefinition of y, right? So the use occurs first. Okay. So what I should mention that we will actually allocate, when you actually construct the data flow graph, you do the annotation, you are going to indicate that. Okay, as you do the annotation, you do not like do what I just did, like you get to this point and then you inspect. Actually, at the annotation stage, you are going to indicate this use x is before the definition. The use of y is before the definition of y. With that in mind, this path definitely for variable y. 1, 2, 5, 6 is this path definitely for variable y.
Yes.
Yes, right?
We define it as a path with the definition of use, not
Right.
just the whole path.
That's right. Okay. So the key point that between definition and the use, you cannot have another definition. Even though we have a definition here, but that is after the use. So that makes the path still a definitely path for variable. So if you understand the motivation why we make it definitely, then it will help you to analyze situations like this. Okay. Is this a definitely path for variable z? 1, 2, 5, 6. Is 1, 2, 5, 6 a definitely path for variable z? No, right? Why?
Node 5.
So you have a redefinition in the middle. Okay. Is this a definitely path for variable count? It's the same thing, right? As y, we have to look.
Right.
Where we come back to the statement, you look at this, actually use occurs before the redefinition, so that is still indefinite.
So there should be some allocation to written define after.
Right, you are supposed to.
It's not like that, yeah.
Right, you need to, basically you need to have additional information to indicate whether the death occurs before or after the use. Yeah, so that you can generate, you can give proper data flow test which you want as next. So I'm going to skip the other two examples. I think that's the same idea. Yeah. You just need to check if there is a redefinition in the middle. Okay, the requirement to make a DU path. The first node has to be a definition, the last node has to be used. That's assumed, right? Because that's what we're going to do. Like we want to test definitions. And then you have to be def clear. And it has to be def clear, it has to be a simple path. Those are the requirements that we want to satisfy to make a new path. Now we're going to talk about some coverage criteria. Okay. Before that, we're going to introduce two notations. One is called the depth path set. Okay. So du and v. Okay. So basically, this notation includes all the du path that begins at node n for variable v, okay, for given variable. So you only specify the starting node of the du path, all the du path, okay, with respect to a given variable. Depth pair, you basically not only specify the starting node and also the ending node. Okay, so, so this notation includes all the DU paths, okay, between between two particular nodes, okay, that starts from a given node and ends at a given node. So by definition, you can see the relationship between these two notations, right? Because the first notation does not specify the ending node. Okay, so the second notation specifies the ending node as well. Okay. And we're going to use these notations to define different coverage criteria. So the first coverage criteria we use in data flow testing is that each DU path in the depth path set is a test requirement. Well, let me put this way, okay? I guess what I said is not quite correct. Okay. So for each depth path set, okay, we only want to test one of them. Okay. As long as you test one DU path from each depth path set, then you satisfy this all depths coverage. It's kind of difficult to understand, right? But intuitively speaking, what this means is that for each definition, you need to test at least one DU path. From another perspective, for each definition, you need to test at least once. Okay? Or from another perspective, every value you put, you give to a variable has to be used at least once. That's the basic requirement. It makes sense, right? If you cannot even use it once, how do you know if that value is correct or not? Right? So that is the basic value. remember, if you look at the notation, that notation includes all possible DU paths, starting from that node, from that definition, right? You only need to test one out of all those paths that starts from that definition. That's the idea of all depths counted. We're going to see examples later on. Okay, I always give you examples, but for now, that's the idea. Okay, all depths. Then we have the second coverage criteria called all uses counted. It means every use has to be tested at least once from a intuitive perspective. The difference between all uses and all depths is that one definition could be used multiple times. Do you want to test like all the different uses, or you just want to test one use, right? How do you make the decision which one you want to? You want to test all uses, or you want to test only one of those uses? It depends, right? Remember, always that's always the right way to answer the question. It depends. If you have a lot of resources, this is definitely more comprehensive than the first one, because it requires, if a definition could be used in multiple locations, you have to test every use at least once. Okay. That's the formal definition, right? Like for each starting node and end node, you have to test one out of all the DU paths between those two nodes. Okay. And we'll give some examples later. But anyway, normally speaking, you have to test every possible use, okay, of every definition. Then we have third coverage criteria. This goes even stronger. That means the reason why we have this one is between a definition and the use, you could have multiple paths, okay, that go from one definition to one use. In the all use criteria, you only require one of the paths between a definition and the use to be tested once. Here you require all the paths between the definition and the use to be tested. So this is going to be more comprehensive. It's going to require more resources for you to do the testing, but very likely it will help you to detect more bugs, right? Again, that's kind of the hierarchy. Okay, I hope by now you get familiar with the way we do things. Okay. Let me show the example first, so that you can get a better idea to see the differences between the different criteria. Okay. So this is a control flow graph. And again, we're not looking at the code. We look at just the graph structure. And again, I hope when you look at the graph, you know it's kind of like two if statements, right? In your code. Okay. Two branching structures. So we have a definition in the first node, n sub 0, and we have two uses here. Okay. So the variable x is used in both nodes here. Okay. If you do all definition coverage, remember, all definition coverage only requires each definition be tested once. Okay. In another way, it's basically means every definition has to be used once. Okay. So to satisfy all depths coverage, I only need one to cover one DU path, okay, which is 0, 1, 3, 4. That is a DU path. Okay. If I test that DU path, I have tested this definition once. Right? If we go to all uses coverage, then this single DU path would not satisfy all uses, right? Because you have two uses here. you only tested one use of the definition. So if you want to achieve all uses coverage, you have to have at least two DO paths, right? 0, 1, 3, 4 is going to test this use, and 0, 1, 3, 5 is going to test the other. Why do you have to test both use? Why like sometimes test one use may not be sufficient? It is. That depends. This does not depend. Okay. The reason is this: if you give an incorrect value over there, it's not like every use is going to expose. It's going to give you correct result, right? In some cases, depends on the way. Well, because it depends as well. It depends on the way the variable is used. Okay. Let me give you an example, right? Okay. If x gets a value, let's say q. Okay. I'm trying to construct the example. If one way to use it, okay, if you say y x plus x, it's one statement, like qx, okay? That's one way to use it, okay? Then you have another statement, let's say y prime, okay? Or you can say z. It only affects the value of y, does not affect the value of z, right?
Right.
It's going to be the same as 1 over 2. Okay? And we do the last one, count is 2, x is 2, y is 2, count is 2. So this is false, come here is 1 over 2, come here you're going to get y would be 2 times 2 plus 1 over 2 is 4.5, right? And then count, now is 2, right? So count is 1, when you evaluate this condition, you're going to go back to the x cube. Okay. So over here, x is 2, right? The value of x has not been changed. So you come back here, so z would be 1.5. You come here, whatever value of y you get really does not matter because you're going to get out of the loop, right? So I'm going to, the output would be 1 over 2, right? The actual output, right? And the expected output will also be 1 over 2. Okay. So for all the test cases you have here, you're going to get the same, get the expected output, okay? And I want to mention that if you look at the control flow graph, these 4 test cases satisfy the branch coverage, right? Because the first test case basically goes to 1, 2, 3, 4, 6, 7, right? The second test case goes to 1, 2, 3, 4, 1, 2, 3, 6, 7, right? The third test case 1, 2, 5, 6, 7. The last test case would be 1, 2, 5. Because this edge has not been tested yet, right? The back edge. That is why count equals 2 in the last test case. It's going to be 1, 2, 5, 6. Go back to 2, and then 5, 6, 7. So if you check the execution of the 4 test cases, you do cover every branch in the control flow graph, but you cannot detect this problem. Okay. If we look at the code, can you see why we cannot detect this bug? Why, like, it's supposed to be, remember the bug is in statement 914, right? It's supposed to be y equals x plus y plus z, right? Why this bug is not detected by these 4 test cases? Can you see why?
Multiplying by 2 and adding 2 to itself is the same thing.
Well,
That would-
that's not the real reason, but that's a good observation. Like, in this case, x plus y is equal to x times y, right? And two plus two is equal to two times two. But this is not the real reason why the bug cannot be
So
detected.
I'm looking to the output, the last value, which is not y in C. So y is not part of the output.
Right. So y is actually never used. You have an incorrect value, but in all the test executions, you never use the value, the incorrect value. How do you, I mean, you always get the correct output, right? So now the question is that, if I want to detect this bug, what test cases I have to use? Well, first, what condition I have to satisfy if I want to detect this bug? You have to use this variable, right? You have to use y. Where this variable is getting used. Where this variable is used. The only place you use this variable is this statement, right? So what this means, if you want to, if you do the, actually if you do the all depth coverage, it's going to require you to create a test case such that you're going to use this definition. At least once, right? This one was, in those test cases, was not used at all. So to use this test, to use this variable, what condition you have to satisfy? You have to go back. You have to go back. So count has to be more than one. Otherwise, it's not going to work. And also, when you go back, you have to execute this branch, right? You cannot execute this else branch. So it means x has to be less than or equal to 0. Okay, and y has to be greater than or equal to 0. Let me see. Okay, I want to give you this assignment. Okay, next class, someone has to come to, maybe whoever arrives latest, have to give me a test case that will detect this bug. I think we have given you some ideas. You have to go back, right? And you have to make sure that statement gets exercised. Then when you output the value z, you're going to see the difference. I hope this is a good exercise for you to do. See, when you understand how data flow works, right? Then you know you need to somehow construct that test case if you want to detect this bug. You can guide your efforts on test case. So take this as a I don't know, like a challenge or exercise. It's probably not a challenge. It should be easy for you to come up with a specific test case to detect this. Okay, I'm going to stop here.